All right, so day 4 is our last lesson before the test next class. So having a system of equations means you have uh, 2 equations. We've already looked at solving systems using, let's see here. I'm just gonna say our calculator. Now let's solve using substitution. All right, so you have 2 equations here. You have x minus y equals 3, or 7x minus y equals negative 3. This form is called substitution. Okay, what we're doing, we're going to choose one equation, we're going to solve, or choose one variable to solve for. Let's just take my top equation. We have x minus y equals 3. We're going to pick a variable to solve for. I'm going to pick the x to solve for, just because if I pick the y, I have to then divide by -1, and that's kind of long. So if we want to solve for x, what do I do here? I add y to both sides. So we end up getting x equals y plus 3. You can solve for whatever letter you want to. I typically look and see which one seems to be the easiest. So here we solve for x. That's all they asked us to do. So we're going to plug that into the other equation. So if this is equation 1, we're going to plug equation 1 into equation 2. Okay? So that means that I have 7x, but instead of x, I'm going to write this right here. Okay, so instead of that, I'm writing y plus 3 because that's what x equals. So 7x minus y equals -3. You got with me so far? That's our substitution. We subbed in one equation in for the other. All right, if I have to distribute this, what do we get? 7y. And what's 7 times 3? Plus 21 minus y is equal to -3. Do I have any like terms? Yep, what are they? So 7y minus y gives me 6y plus 21 is equal to -3. Okay, I'm going to draw an arrow over here so I can have some space to solve it. Alright, how do I solve for y? Good, let's subtract 21. So we're left with 6y is equal to -24. Now what? Divide by 6. Divide by 6. So y equals -4. So now we did all that work to figure out what is y. Alright, the last part says you should, so you solve for one variable. Okay, we have our y. Good job. Now plug that into the original equation and solve for the remaining variable. So my main equation was the first one. Let's go back to just the original. X minus y equals 3. Alright, so I have x minus, instead of y, I'm going to write what? -4 equals 3. So I picked an equation, solve for x, plug that into the other equation, got my y, plug that back into the original. It's like a little cycle. Well, I know that this is really x plus 4, right? It's a double negative. How do I solve for x? -4. So x equals -1. So now I have a y, and now I have an x. Alright, this is the long way. This is substitution because we subbed in one equation for the other, we found the variables. So, do you guys have, see your packet for a second? I just put it on a different page. Please don't do this to me today. Alright. So remember to write your answer as an ordered pair. My ordered pair would be what? What was my x? -1, what was my y? Alright, so that would be my solution. If you were to graph this system of equations, this would be the solution. Alright, so that is another way we can do it. I do not recommend that way. I recommend doing it the easy way. When I say easy way, that means solving for x. Alright, so you guys have calculator steps on your paper. Your calculator steps are essentially what we've been doing already. So let's just get to it. What we're going to do, we're going to put everything in y equals. Alright? My second equation is already in y equals, right? I'm not doing anything with that. If you have different colors, you can use them. Make sure that you have enough space. So let's solve for y. 2x plus y is equal to 7. How do I solve for y here? Put a minus 2x to the other side. That cancels out, so I have y equals -2x plus 7. Alright? So I have one y equals, I have my other y equals. Once you have your y equals, I want you to grab your calculators. Alright, so in your calculator, let's type in my first equation. Y equals -2x plus 7. Scroll down. What's my second equation? Y equals 3, so we just put the number 3. Let's graph it. Let's see what it looks like. Alright, so there's my graph. What do I do if I want to get an intersection? Who remembers? Second trace. Which number do I need? 5. And I'm going to just move my cursor to where my lines are intersecting. And all you have to do is press enter 3 times. What's my intersection there? 2, 3. So you could have done that the other way, which is putting it, like doing substitution and plugging in the y into there and then back to the original, and that's a mess. We have our answer right here. So this is your final answer. When they're asking, find the intersection of the points, you solve for y, graph it, find your intersection. So far, so good? All right. Number 2, let's take this first equation. We have x squared equals 8y. What do I do when I solve for y? Divide by 8, right? That cancels out. So that means that I have y equals x squared over 8. So you like that. If you want to box it up just so you can not get lost in your work. Alright, when I solve for the other guy, it is x squared equals 2y plus 12. I want to subtract 12 from each side. So I have x squared minus 12 is equal to 2y. I divide by 2. Divide by 2. You can leave this answer like this. I would just put it in parentheses. So when you put it into your calculator, the top part goes into parentheses and then you do divide by 2. If not, your calculator will only divide the 12 by 2. So let's go ahead and grab our calculators. Alright, so go to my y equals. I'm typing in, let's see here, we have parentheses x squared divided by 8. My next one is going to be parentheses x squared minus 12. Yep, divided by 2. If you don't put the parentheses, then it's just going, the first one really doesn't matter, but the second one does because your calculator is only going to divide this last number, not the whole thing. So anytime that there's a fraction, I always put in parentheses. And then we graph it. Should be 2 parabolas. All right, how many solutions do I have here? I have 2 solutions. So second trace, intersection. I'm going to do the one on the left first. My first intersection is negative 4, 2. Let's find the second. Second trace. Every time you find an intersection, you have to do that. And then I scroll all the way over to the right intersection. What'd you guys get for this one? 4, 2, good. The intersection here is that's my answer. You guys getting this? Pretty easy. The hardest part, believe it or not, is just making sure you're taking your time on how to solve for y. Because if you write it in the wrong equation, then your whole solution is wrong. Alright, so we're not going to do all of these. Let's do 3 and 4, and then I'll let you guys work on your own. Alright, so let's solve for y here. I subtract x. So I'm left with y equals negative x plus 6. That's my y equals, so I'm good. My second equation. I'm going to subtract 3x. I'm left with 3y is equal to negative 3x plus 18. Divide by 3 on both sides. I have y by itself. You can leave it like this and just put the top in parentheses divided by 3. Or you can reduce it. We have negative x plus 6. Do you guys see anything familiar with these 2 problems? The same exact line. What does that mean? What's my solution? Go from the I. Infinite. We didn't even have to graph that one. Because we have infinite solutions. Same exact line. Even if you would have just graphed it, you would have seen that both lines would be the same exact line. So we have infinite solutions. So far, so good? This table, you good? This one, you good? Middle table? You guys? That's pretty good at solving for y. Alright, so here, we have y minus x squared plus 2x equals 4. I want to move everything away from the y. So that's pretty easy. I'm just going to add x squared and subtract 2x from both sides. So I'm left with, on this side, that goes away, that goes away. I have y equals positive x squared minus 2x plus 4. I like to keep it in standard form. Because we're putting it into the calculator, it really doesn't matter if you put like the 4 first, or 4 plus x squared minus 2x. It doesn't matter. It just looks a little weird. Your calculator would still recognize it. Alright, my second equation, a little longer. I have 3y minus 3x squared plus 6x equals 10. We're going to move everything away from my y, so that means I'm going to add 3x squared and subtract 6x from both sides. Just do it all in one step. Sorry. So on the left side, those two guys cancel out. I'm left with 3y is equal to 3x squared minus 6x plus 10. Alright, and since I want x by itself, y by itself, I divide by 3 on both sides. So you have y equals, I probably would just leave this as a fraction as it is. If you want to reduce it, you can. You'll get x squared minus 2x plus 10 over 3. So you would still have a fraction at the very end if you want it. But it's probably easier to just do it like this. With the whole top in parentheses and divide by 3. If you want to reduce it, you can do that. You would have y equals x squared minus 2x plus 10 over 3. Alright, so I'm going to grab my calculator.
You want to do that too? That's what I'm talking about.
You might not need any.
I know, thank you, thank you, thank you.
Alright, I'm going to put this in my calculator. The first one is x squared minus 2x plus 4. The second one, 3x squared minus 6x plus 10 divided by 3. It looks like no solution. You guys see how the red line or the red graph is like a little bit on the outside of the blue one? Yeah, that one's not crossing. So this should be Oh, we did all that work. Our answer would be no solution. All right, I'm gonna leave you guys to work on the last three. I'll put answers up. All right, so you guys have to number 5, right? Here's number 5. Did we get it right? You guys hit this? These two solutions?
Yes.
1 -4 and 2 -1. All right, number 6. Number 6 looks like it was a little, did you have to like zoom out or anything for this one? 2 and -22 is kind of far. How do we feel about this one, guys?
How do you zoom in?
All right, so let me do this one.
Someone asking.
I always zoom fit because then I know that my graph is going to be in the grid. It just goes as far as it needs to. So you have parentheses negative x squared. Yeah, so it didn't show because if a solution is at 22 is what it said, then it's not going to be in your grid. But you know we've got to have 2 solutions, right? So then we have negative x minus 20 is our other equation. All right, if I graph this, come on. Okay, so I can't see anything in this. So what I'm going to do is when I hit zoom and I go down to fit, which I think is 0. So zoom fit, which is zoom 0, press enter. And it should do it again so you can see what's important. You'll see the solutions. So zoom fit always works, which is why I use this more than I use zoom out, because if you do zoom out, you may have to do it like 3 or 4 times. So then I could do second trace, intersection, then we're going to hit enter. So that's how we get -9, -11. And then I hit second trace and I get the other intersection. This must be the -22. And then I hit enter. Oh, this is 6, -26. So my numbers are wrong. This should be 9, 11, and 6, -26. Did you guys get these numbers, or you didn't even see it in your graph? I hope I graphed it right, because I don't know how I got these answers on my notes from last year. And then I didn't even get to this one. Did you guys see number 7? Did you get there? Okay, it's fine. All right, so look at your homework.